You remember the four types of orbitals. There's the s orbital, p orbital, d orbital, and f orbital. Now the s, that's the spherical orbital, and it can fit up to 2 electrons. The p orbital is the one that's shaped kind of like dumbbells, and it can hold up to 6 electrons. The d can hold up to 10, and the f can hold up to 14. Now our question is this: which orbital will an electron go into first? Before I get into that, let's talk about a new property of electrons. Now, physicists say that electrons have spin. Now, this doesn't mean that they actually spin around. It's just a name that they use to describe a property of electrons. It's just like they say that quarks have 6 flavors, even though they don't actually taste any different. Okay, so electrons have spin. That spin can be positive or negative. If the electron has a positive spin, then the way that we represent that is half of an arrow that points up. So this is a regular arrow. The way that they draw is just half of that arrow. And then for a negative spin electron, that's a half arrow pointing down. Okay, so the way that electrons are placed in orbitals, there is a specific rule that they have to follow. An orbital can only have up to 2 electrons at a time. So we'll represent an orbital with a horizontal line, and we can fit 2 electrons in there. Those electrons have to have opposite spin. We can have a positive and a negative. We don't ever see a positive and a positive or a negative and a negative. That's very unstable. The electrons don't like interacting like that, and so they'll just fly apart. However, this one is good. They have a positive and a negative. They have opposite spin, so it's going to be very stable that way. Okay, so let's return to electron placement in orbitals. If an atom has a p orbital, let's say a px, py, and pz. Remember, each one of these lines can fit 2 electrons, and if the p orbital can fit 6 electrons total, we need to have 3 lines here. If I'm trying to put 5 electrons into this p orbital, there's a specific order that I have to follow in order to do this. The way that you place electrons, you always try and give them as much space as possible, because electrons are kind of space hogs. So they'll distribute themselves across as many orbitals or as many of these lines as possible before they start to pair up like they do over here. So we're going to distribute the positive spin electrons first. So I've got 5 electrons. Here is 1, 2, 3. At this point, I've used up all of my lines, and so now I need to start back at the beginning and pair them up, this time with negative spin electrons. 4, 5. Okay, so pretty easy, right? How about we try one with a d orbital? So a d orbital can have up to 10 electrons, so we'll need 5 lines. 1, 2, 3, 4, 5. And this time, I'll put 7 electrons into that orbital. Okay, so same rule as before. We're going to distribute all of the positive spin electrons to each one of these lines before we go back and start adding in the negative spin electrons. Okay, so we've got 1, 2, 3, 4, 5. Now I can go back with the negatives. 6, 7. It is perfectly okay that these guys are unpaired. They aren't going to rearrange themselves so that they are in pairs, because they like to take up as much room as possible. Let's say that we only had 4 electrons to fit into that d orbital. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now this one has been left alone entirely. There aren't any electrons in it. That doesn't mean that this isn't a d orbital because the line is still there. If we had more electrons, they could go in there. However, since we don't have those electrons, we're just going to leave it blank, and this is just fine the way that it is. Okay, how about an f orbital now? That one can hold up to 14 electrons, so we're going to need to put 7 lines. 1, 2, 3, 4, 5, 6, 7. Okay, how about I put 13 electrons into this f orbital? I'm going to go with the positives first, all the way across, then double back for the negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Pretty easy, right? How about an s orbital? Now this one can only have 2 electrons in it, so all we need to do is draw one line, and there's our s orbital. If I have just 1 electron to put in there, that's it. If I have 2 electrons, that's it. However, if I want to put more than just those 2 electrons in there, I need to add another orbital. So let's make things a little more tricky. Let's say that I have an s orbital and a p orbital. So here's my s, it only has 1 line, and my p orbital, which has 3 lines, one for the px, py, and pz. Okay, I have, let's say, 5 electrons to fit between these 2 orbitals. Before I can do anything, I have another rule that you need to know about. So, in order to fill up multiple orbitals, you always fill one orbital completely before you move on to the next orbital. Okay, so what do I mean by filling it completely? The s orbital, that can hold up to 2 electrons, so I need to put 2 electrons into this orbital before I can even touch any of these lines in the p orbital. So if I have 5 electrons, what I'm going to do is draw my positive, and before I can move over to the p orbitals, I have to fill in this one. So here is a negative. So I've got 2 electrons over there. Then I have 3 more to put into the p orbital. I'm not going to double it up on this one yet. I have to distribute them as I did before with a positive in each one of the lines before I double back and fill in with the negatives. So here's 1, 2, 3, 4, 5. Okay, let's make things a little trickier. I've got 1 s orbital. I have a second s orbital. I'll call this one 1s and 2s, just to tell the difference between them. And I have a p orbital. This time I have 10 electrons. So what I'm going to do is fill this one completely, then fill this one completely, and then distribute any remaining electrons into this last orbital. So I've got my positive, and I can't move over to the 2s yet because I have to fill this one up first. Here's my negative, positive, negative, and I've got 2, 4, 5, 6, 7, 8, 9, 10. So I've got all 10 electrons distributed between these 3 separate orbitals. Okay, last example. I have a whole bunch of orbitals this time. I have 1s, 2s, I've got another p orbital. Here is a 3s orbital. Here's another p orbital. I'm going to call this one 2p and this one 3p. Don't worry about where I'm getting these numbers from. That'll be explained in the next lecture. I have a 4th s orbital, and 1, 2, 3, 4, 5. This is a d orbital, and I'm going to call this the 3d orbital. Okay, now I have 24 electrons. So I'm following the same rules that I did before. I have to fill up each one of these orbitals before I can move on to the next one. And I'm going to fill in the positives first before I fill in all the negatives. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So once again, it's okay that these guys are unpaired. It's okay that this one doesn't have any electrons in it. It's perfectly happy the way that it is. So if you have any questions about what I just went over, please send me a message on ngrade. Otherwise, enjoy the rest of your Eid break.